Okay, well, we'll take a look at today's lecture. And so, as per usual, you can do git pull upstream main, and lecture 3.1 is up there. And so we will continue talking about lists and strings. And these are important data structures that exist in Python, and we'll go from there. So we'll get into some of this. A lot of this is so I'm adapting this a lot from a kind of a little book called Whirlwind Tour of Python by Jake Vanderplas, as well as Think Python by Alan B. Downey. Both of these are freely accessible on the internet. Just do a little search for each of these things. Think Python I've linked in the syllabus, and if you just search for Whirlwind Tour, you can download that as well. I do recommend that you also read the recommended textbooks as well. Okay, so we talked about this a bit on Friday, but lists are mutable, okay, which means the object themselves can be changed. So you have an object in memory. So the way things work in Python is, you create some object in memory, and then you have a name that points to that object in memory. Okay, and so here I've created a list. We create the list using square brackets, and I'm pointing the name fam to this object in memory. Okay, and then here I take the name second and I point it to fam, and so this will actually point to the same object in memory. Okay, and here we say, all right, take that object, okay, and then take the 0 index thing and replace it with sister. Okay, so we're going to go from Liz to sister. And if we say, okay, print out what second is, it's going to print out the list, and now the first item, or the index 0 item, is now sister. And then we say print fam, and because fam and second are pointing to the same object in memory, okay, that this thing also has been modified. Okay, so fam and second have both been modified. Okay, whereas over here, I create, I'm going to start over. I create this object in memory, and fam points to that object in memory. Here we create a copy. Okay, so we have the object. We create a separate copy. We now have 2 separate objects in memory. Okay, another way you could create a copy is you could just take the list and do .copy, and that will create a copy. Okay, and here I say modify the 0 index element to sister. And so when I print out second, which is the second list, that has been modified. That object in memory has been modified, whereas the original object has not been modified, because second, this thing, is a copy of fam, right? So that's kind of the difference, right? If you point this to this, which is kind of the difference here, they're pointing to the same object. Here, this is pointing to a copy. All right. Here's another example. Okay. Here I just did fam.copy, and then here I changed this number, the second value, the index 1 object, or index 1 value, which is the number. We change it from 1.73 to 1.65, and we point to that. And again, that the original fam is left unchanged, and third has been changed. Okay. Similar type of thing. Okay. Here, this is another way to kind of make a copy. So here, fam takes on the value with 1.73 right here, and I could say make a list out of fam, right? And that's going to be list 2. Okay, and then in list 2, we change the index 1 value to 1.9. Okay, and so when I print out list 2, it's been changed, and then fam itself has not been changed, right? So these are all just, I guess these are 3 ways to create a list. One is you use colon, square brackets with a colon to kind of slice the whole thing, right? Slice the whole thing will create a copy. You can do .copy, that's going to create a copy. And then you can also just take the list and make a list out of that list, and that will create a copy. So all of these things are copies. Okay. And the one thing about list slicing, and this is a little bit of an aside, but you can take a list assignment and then assign it to a slice, and that will do the assignment. Okay, so here, this is the current values inside FAM, and here I'm going to say take the slice from 1 to 3, which is this section, and basically set those values to 1.8 comma Jenny, and so those values get inserted into that slice, which is a useful feature, right? So you can kind of take these things and just assign it right into that spot. Okay, and again, you just kind of have to get used to the way Python does the list slicing as far as the numbers go, but that will do it. Okay. So we saw list copy. There's another feature called append, right? And that's going to just tack on an item to the end of the list, right? And so it's equivalent to taking kind of taking a slice and taking whatever X is and appending it to the end. So here I create this list fam. Each time I use these square brackets, I'm creating effectively a brand new object in memory. So I'm creating this this list here, and then I'm going to say take this value, this string me, okay, and we're going to append it, okay. All right. Oh, so we have a question about the shallow copy, and I will address that on the next slide. Okay, good. It's a good question, and I'll address it. Okay, and so we've got we're going to append this, and all that does is it tacks on the value me to there. Okay. Now you got to be careful. Oh, okay. You can also append items by doing plus. Okay. So you could take a list. This is a list. And you can do plus, and you do another list, and it's going to tack them on, okay? Now notice there's a difference here. Here I just did fam.append, okay? So I'm taking the name of the list, and I'm doing .append, and it modifies the list itself, okay? Over here, this actually doesn't modify the list itself. If I want to modify the list, I have to use the assignment. I have to say reassign the name fam back to this thing, right? So we're going to do fam, and it's going to tack on the value 1.8, and then we're going to assign it back to the name fam, right? And so that way fam now kind of captures this, okay? Otherwise, it's kind of just like shouting into the void. You know, if you just did 6 plus 7, it would come back and say it's 13, but that number 13 isn't stored anywhere, right? You have to store it back somewhere, okay? Okay, so again, fam.append is just going to tack values on, okay? Now, if you try doing something like this, where you append a list, an iterable here, okay, it's going to take this and actually append the entire list itself as one item here. And it changes the format. This is still one list. It just suddenly prints vertically just because it doesn't fit on one line. So when Python realizes that like we've run out of space, it can't fit any more stuff in this region, it just starts printing the list vertically, okay? But you can see that now we have a nested list inside of the list, right? And if you actually wanted these values to be appended, you have to kind of, you'd have to use the plus sign, okay? And so if you do the plus sign, then these values get appended, okay? They get added onto the list. So the plus sign, I would say, is probably easier for a lot of things, and yeah. Is square bracket and writing list equivalent? I think so. I think almost in. I mean, obviously you can't slice with list parentheses, but as far as list creation, square bracket and list are the same. I'm trying to think of like some kind of edge case, and it's not coming to mind. But you know, obviously you can't do like list slicing with list parentheses. But list parentheses is used for creation, and square bracket, if you just enter values in there, will also be used for creation, and that's fine. Okay. All right, and then again, because I didn't write fam equals fam plus this, fam remains the kind of the original list unchanged. Okay, that's what this is here to show. Okay, so let's talk about this whole copy. You know, we talked about shallow copies. All right, so if we have a shallow copy, then you assume there's got to be something else like a deep copy. Okay, and so we do have a shallow copy and a deep copy. Okay, and so list.copy is going to create a shallow copy. List with the colon will create shallow copies. Okay, and so what a shallow copy is it creates a copy of the list. But if the list contains other objects, then those objects, only the references get copied, but not the objects themselves don't get copied, okay? Whereas a deep copy will copy the list and create copies of the objects that are referenced inside the list. So let me just kind of show you here, okay? So this is a shallow copy and a deep copy, right? So I've got A, B, C. I've got lists A, B, and C, okay? A has the string A, numbers 1, 2. B has the string B, 3, 4. And C is a list consisting of object A and object B. Okay, so C is a list consisting of object A and object B. And so if I print out C, okay, it's basically going to be object A with A12 and object B with B34. Okay, now what I'm going to do is D is a shallow copy of a shallow copy of C, and E is a deep copy of C. Okay, so again, C contains object A and object B. D is going to be a shallow copy of C, and E is going to be a deep copy of C. Okay, and so what I'm going to do here is I'm going to take object C and I'm going to append the value X to it. All right, so I append the value X to that, and so X now C now has the value X string as a third thing, and because D and E are copies of it, they don't include X either. Okay, this is the difference between a shallow copy and a deep copy, though. Okay, here I'm going to take object A, list A, and I'm going to append the value Z to it. Okay, I'm going to append the value Z to it. All right, so keep in mind C contains a reference to object A and a reference to object B. Okay, and so when I print out C, C now has, because it's referring to object A, it now has Z inside the list for A. Okay, and C, also has the object B and also has the object or value X that we appended. Okay, D is a shallow copy of C, right? Remember, we created D to be a shallow copy of C. And so that creates a reference to object A. And because object A has been modified to include, to be appended with the value Z, object D, which is a copy of C, also has that change where Z is now appended to A. Okay. But again, because D was a copy and, we changed C to have X, D is not going to have X. Okay. And E is a deep copy of C. E is a deep copy of C. So it created a copy of object A and it created a copy of object B. This copy of object A is no longer referenced by this name A. Okay. So when we modified object A, which is this list, and added the value Z to it, that's not gonna, it doesn't affect what happened in E because E is a deep copy. Does that kind of make sense? The difference between shallow copy and deep copy? So you'd have to study this slide. Okay. Now, deep copy is not something available in the base library of Python. I mean, it is part of base Python, but you do have to import the copy library. All right. So the copy library contains a bunch of like methods for copying stuff. And one of them is copy.deepcopy. And so that's what this will do. So the normal copy syntax creates shallow copies, which if you have objects embedded inside other objects, it's going to preserve those references to those objects. Okay, so I hope that answers your questions about copies versus deep copies, and that's this slide. Okay, so and you can always go online and read more about deep copies versus shallow copies, but I think this captures pretty much the gist of the difference. Okay, All right, so other things about lists, we've got insert, we've got extend, okay? So list insert is going to take some object X and put it into index position I, okay? So so if you put it, if you have insert 0, it's going to put it as the first thing. And if you put insert into, length A, it'll put it at the very end, which is pretty much the same thing as append. And again, as far as insert goes, you can only do one thing, okay? You can only do one thing. So if you have like an iterable, if you've got a list, it's going to insert the entire list inside. So you're going to end up like nesting a list inside the other thing. Whereas extend allows for an iterable, allows for a list, and it's going to extend the list accordingly, right? So this is just kind of an example. So here we're going to say, all right, here's our list here. We're going to insert Joe into index position 4, right? So index position 4 would be 0, 1, 2, 3, 4, and it gets positioned between 1.68 and mom. You can kind of think of it as, inserting it at the numbered comma, right? So here it's going to be insert it basically where the 4th comma is when you say insert 4, and you can think of it as going at the 4th comma, which is between 1.68 and mom. Okay. Here, if I say insert and I give it a list, again, it just inserts the entire object itself. And so the entire object gets inserted between 1.68 at mom and the kind of the position where the 4th comma is. Okay. And if you try to give it more than one thing, you get an error, right? So insert's not going to let you just kind of do these things, right? So if you wanted to insert Joe and 2.0 into that, let me do the extend first, and then I'll talk about inserting into the position there. So here you can do extend, and you can give it an iterable like Joe and 2.0, and it actually extends the list. It doesn't insert the object. You don't have a nested list here. Okay. So, and if you wanted to do something like insert multiple values into this position here without having a nested list in the result, you can use assignment with list slicing. And so here we're going to slice basically to 4:4, which is basically this 4th comma, and we're going to use assignment, and the values get in here. Okay, so this is kind of a frequently used idiom in Python because you don't have like an actual method, right? So insert will allow you to only put in one thing, and so if you try to put in multiple things via a list, you're gonna have a nested list, and that's usually not what you want. And so if you wanted to do something like that, you're going to use assignment in conjunction with list slicing, and that'll take care of it. Okay, other methods that are available for lists. Oh, you know what? Let me give you, before I get into that, let me give you your first view quiz answer for today. First view quiz answer is the letter A as an apple. A as an apple for week 3, Monday. A as an apple. Okay. What am I saying? Oh, okay. Remove the item, right? So you're gonna, it's going to remove whatever item has this value X. Okay. Pop is going to remove the item at index I, index position I, and it will actually return that value, right? So this will not only modify the list, but it will return that value. And then here, this will just delete everything in the list, list.clear, okay? So here I've got the list, and you can say, oh, you know what? I want to remove this thing, and it's going to remove the name Liz from the thing, right? If you have multiple instances of it, it's going to just remove the first item. And if this thing doesn't even exist in the list, it's going to give back an error. All right, so here is pop. And if you don't specify an index, it's going to just pop the last value. Okay, so it's kind of like taking something out of a stack. So it's going to just take the last value off. it returns the value. Okay, so you can actually capture the value of pop into say J, and it's going to return the value that quote got popped off. And here, as far as fam goes, it no longer has that last item. All right, so here's another index. So you can do fam pop 0, and it's going to remove the first one. Okay, so this is kind of like using a queue, first in, first out. Okay, and that's going to remove the first thing. So you've got Liz, and that gets removed, and the resulting list no longer has the first item. Okay, and if you do fam.clear, it just deletes everything inside the list. And again, you might say, like, why bother with this? Why don't I just use square bracket, empty square brackets if I wanted to empty a new list? And again, the difference is, if I just said fam equals single square brackets, basically I would be creating a new list that's empty in memory rather than taking the current list and modifying it, right? So fam.clear takes the currently existing list that exists in memory and clears it so that there's nothing inside. Whereas if I said, if I just reassigned the name fam to square brackets with nothing inside, that's creating a new empty list and kind of breaking the pointer from the old list to the new empty list. Okay, and it's a subtle difference, and sometimes in a lot of cases there's no difference to the end experience, but in some cases you actually do want to modify that list, modify that object rather than just creating a new thing entirely. All right, as far as list index goes, you take the name of the list, right? And so here I do fam.index, and I say, what is the index of the item Emma? Okay, and it's going to come back, and it's going to say number 2, right? So it's going to say Emma is in position 2. If you give it something that doesn't exist, right, you're going to get an error back. It's going to say, that item doesn't exist in the thing. So here, if I say, what is the index of the number 3, and it says, nope, 3 is not on the list. And then list.count comes back and says, this is how many times the thing appears. So here I created a new list consisting of A, B, C, A, and I say, how many times does count how many times A appears in the list? And it says it appears 3 times. Okay. Can you use count with missing values? So one thing about Python is that you don't have a missing value. There's no NA in Python. You have nan, okay? Nan, which is not a number, and that's frequently used for missing values. So if you want to kind of store something missing in Python, we frequently use not a number, NaN, but that's technically a value in of itself, right? It's a type double, not a number thing. And so you can say, find this thing nan, and that'll be stored in the list. But there's technically there's no specific missing value case, if that's all right. Yeah. So it's a subtle distinction, but yeah, you can search for nans and things like that, but that's specifically the nan value, not there's no specific missing value thing. All right, so here you can say here I've got nested lists. I've got 4 lists nested inside a larger list, and so here if I say does the string Emma appear in here, it comes back and it says no, that doesn't appear anywhere, because that's not an element that's inside the primary list, right? Inside the primary list is a list of length 4, and Emma is not one of the objects in that list, right? Instead, the list containing the string Emma and the number 1.68 is an object that is inside this primary list, and it's going to say that appears 1 time. But but the string Emma itself, so fam.count doesn't kind of do recursive search. It only just searches top level elements. Right. You can also sort a list. Okay, and you've already seen this. This has already been shown up in your homework, but you can kind of take a look here, and then reverse will just reverse the order of items in the list. Okay, so here, if this is fam, here I did fam.reverse, and it just took the elements in the list and it reversed them. There's nothing to capture, it just does it. Okay, and so here Liz now appears as the last item, and the height 1.89 appears as the first item. If you try to run fam.sort on a mixture of strings and floats, it comes back with an error. It says I can't do that, right? You can, if all of these numbers were strings, then it can sort. It is able to sort strings that contain numeric values, okay? But it doesn't know how to sort float values themselves. So here are some digits. You can sort them, and it will preserve the numeric data types. So here I've got this list is a mixture of integers and floats, or basically just one float, a bunch of integers, and it will sort those. It will sort those appropriately. Okay, so float, the fourth index 4 item, the fifth value is a float. Everything else is also true. Here, you can reverse it, and that's fine. Here I've created a new list, and you can also just run sorted, and that's going to sort the list or return the list sorted, but the original list remains unaffected. Okay, and you already, this has already been brought up in your homework, and you guys have already explored this and seen how it works. Okay, so that covers stuff on lists, and we should be able to get through the stuff on strings. Strings are strings, and but they are sequences. They're treated like sequences, kind of like, much like a list. Before I get into that, let me go ahead and give you your second view quiz answer for today. Your second view quiz answer for today is B. B as in bear. B as in bear for your second quiz answer, view quiz answer today. Okay, so here I just have the name fruit, and it contains the string bananas. Okay, but you can treat it much like a sequence, almost like you can treat it almost like a list. Okay, almost like a list, and you can subset the string, and you can say, give me the character at position 0, and it's going to be the letter B, the first letter. Okay, give me the character at position 1, and that's going to give me A, right? And then just like lists, if you do -1 or a list slicing, -1 will give you, from the end. So this will give you the letter S. And, if you try to say, give me the value at position 1.5, it comes back with an error and says, you're not allowed to give me a float as far as like, in the same way you can't subset a list using a float, you can't subset a string using a list or using a float either. Okay. And much like with a list, you can say, give me the length of a list. Okay. You can say, give me the length of the string. Okay. And it's going to come back and it's going to say, 7 characters. Right. So this is an interesting design choice, but it's a very useful one that the creators of Python did. And they said, you know what? People are familiar with lists and how those operate and kind of the things that work there. And we're going to treat strings in kind of a similar fashion for that we do lists. Okay. And so you can kind of subset and slice a list much like you would slice a list. And we haven't talked about tuples, but tuples act a lot like lists, except that they are immutable and you can't modify them. But we'll get into that later. So if you wanted to slice 4 through 9, okay, that's going to slice from E through I. Okay, and there's no commas here, but again, you could pretend like there are commas in between every single character, and you can say, or I guess they're technically non-word boundaries. You can, find, you're basically slicing from each kind of character boundary here. And so you're going from E to I. And that's what slicing the fourth is. And if you say, slice from -6, so on, you're going to get the last 6 letters in the string. And you could, much like a list, you can go, for every character in this slice here from 0 to 5, go through for each thing and then, do something to it. Okay. And so this is what you can do. Okay. So you can subset strings much like lists. Okay. One thing about the strings, though, and in the same way, tuples are immutable in that you cannot take a string and modify it in place. Okay. So you cannot. So here my string S is the lowercase alphabet, A through Z. I cannot just say, you know what, I want to replace the first character in this string with the letter B. Okay, strings are immutable. You are not allowed to modify them. So if I tried to do something like that, where I would say, take the first character, the character at position 0, and change it to the letter B, it's going to say, you're not allowed to do something like that. Okay. Whereas, you could do this with a list. Okay. You can do this with a list. You can't do it with a tuple, and you can't do it with a string either. So if you wanted to do something like that, if you wanted to change the first character to the B, you'd have to basically create an entirely new string. And you'd say, all right, I'm going to create a new string where the character is B, and I'm going to add on everything from that original string from index 1 through, the last. So I could create a new string, and this is an entirely new string. Right. And so the way strings work in memory is every time you have a new string, or even the same string, they actually point to the kind of that you have different objects in memory, right? So anytime you have different strings, they're pointing to the different objects here. Okay. You also have some kind of methods specific to strings that deal with kind of like capitalization and lowercase and things where you can kind of like modify strings and things like that, right? And so all of these all return copies of the original string, because again, strings themselves are immutable. They are not changed, right? So here, if I say take name and do dot upper, it's going to take put out all the characters that can be made uppercase, if those are going to be made uppercase. Okay. Capitalize takes the very first character, makes it capital. Okay. And everything else will be lowercase. Title case is the first character of every single word. So everything that comes after a space will be capitalized, right? And so, I guess in English, and as far as like writing titles for a book, there's certain rules about like prepositions don't get capitalized, prepositions and conjunctions and those types of words don't get capitalized. So technically, the word "and" shouldn't be capitalized, and "for" and things like that, articles and things like that won't get capitalized, but it doesn't know that. Okay, so it's just going to capitalize anything that appears after a space will basically be capitalized. Okay, lowercase, right? And then again, the original string itself is unmodified, which looks like this. Okay, much like so you can go and you can count how many times the letter appears by just using the count method. Like, so here I wrote like a loop, and this will work. Okay, so you can do for every letter in the name, how many, if the letter is equal to E, then add 1 to the count. I could have just done count plus equals 1. Okay, and that would work. Okay, but you can just do name.count and then the character E. Okay, and this is much like, again, if you had a list. If you had a list where everything was just individual characters, this is how you would achieve basically that task of just counting the letters in the list. Okay, so this is pretty much a method that exists in lists and also exists in with strings as well. Okay, and then index works just like the other like index for a list. Okay, so the way it worked for list, you can do, you know, what is the index of the character A, and it's going to give you the first instance. So again, the original string is stats Python, and it's technically this. Okay, so the capital A appears in index position 2, and actually that's the only instance. But if I ask for the lowercase t, it would give me the index position, and I don't know what that is. Looks like index 10 or 9 or something like that. Okay, and it would just give you the first instance. Okay, and even though the lowercase t appears multiple times in the string, it only gives you the first instance. Okay, there's also a couple other attributes of a string. Okay, and so you can say, you know, does it end with the letter K, the character lowercase k, and that's going to be a true or false value, right? And there's also kind of starts with and things like that. So, you know, it says another technology things for data science, which ends with the lowercase e. So you have that. You have starts with, and everything with strings is case sensitive. So here I said starts with lowercase s, and that's going to be false. It starts with a capital S or uppercase S. Okay, you can also create multiple multi-line strings, and it's difficult to see, but this is actually multi-line, right? And if you want to create a multi-line string, you can use triple quotes. Triple quote marks will allow you to create a multi-line string. Okay, so here I have space, 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 Miles Chen, space, new line. And indeed, that's what I have here. Space, 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 Miles Chen, new line. And that's what we get. Okay. If you use .strip removes any extra white space from the thing, right? So I've got leading white space, I have trailing white space, which are new line characters, and those all get removed. Okay. If you ask for the name itself, right? So the original thing, right? So this thing gives you kind of what the string looks like with the white space removed, but it doesn't actually modify the string itself, okay? And so if you say, well, what is that string? It comes back and it says space, 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 new line, okay? Three new line characters, right? And this, and notice the difference between this and this, right? So print name2 has the new line characters appear as actual new lines when it gets printed out. Whereas when you ask, what is the object itself? The object itself carries kind of the code that says this is the new line, right? So if you wanted the new line characters to appear as actual new lines, you would have, you would need to use the command print. Whereas if you just want the contents of the string, where the new lines appear as, I guess the new line symbols, you know, you can just ask for the object itself. So there is a difference between print and writing the name itself. Okay. One of the most useful methods is string split. Okay, and so this is like going to be super commonly used. And what it does is it takes a string, and wherever there is white space, it's going to split it. Okay, and then it's going to return a list with kind of a list of strings where each element basically is the result of splitting it. Okay, by default it uses white space. Okay, but you can also specify different arguments. So if I take this, right, it sees adjacent white space. So all of this white space it sees as kind of one chunk of white space. All of this white space it sees as a chunk of white space. And so the result is this list that says Miles and then Chen. Here, so here's kind of another, you know, instance. If you have string information, like a stream of numbers coming in here, right? So you can do string split. By default, it splits on white space, so there's nothing to split here. It has one string. This is a list of one item, the string 2, 3, 4, 7, 8. Whereas here you can say, you know what, I want to split on the commas, okay, and it returns a list of strings. string 2, string 3, string 4, string 7, and string 8. So this is a list of length 5, okay? And then if you wanted to convert those to actual values, you can then take the string and put it inside the function int, okay, or float, or whatever it is, right? And int or float or string or whatever these things will try to take whatever object you give it and will try to convert it into, you know, the desired type. So here it's going to take the string 2 and it's going to try to convert it into an integer, and it succeeds, and it gives us the number 2. Okay, this is technically called a list comprehension. All right, so I could have written a for loop, and we could have said, you know, for, you know, x in you know, number string dot split, okay, or, you know, whatever this result is, you know, go through and append these items to the list. But here you can kind of see what's already happening, and we'll cover this a little bit in more detail. We're just giving you a taste of things to come. You know, it's just going to say basically for, you know, for each item in this thing, okay, which is currently just a string, you know, put that string inside int x, and that's going to convert it into an integer, and have it put the entire thing inside square brackets. And that tells Python, try to make a list out of this, okay? Try to make a list out of it. And it succeeds, and we get a list out of this, okay? You know, if you didn't want to do a list comprehension, you could write this like this. You could start off with an empty list, and you can do L append int x, and you get the same result as well. Okay. So whatever you're comfortable with, but list comprehensions are a really nice thing that Python does, and it's worth spending a little bit of time in a future lecture on it. Oh boy, I'm going to run out of time soon. Okay, so there's a few things, a few traits that are just you know, Boolean values. You can say true or false. And so is alpha is going to come back, and it's going to say if the string contains only alphabet characters. Okay, alphabet characters. So name, which is this has a spaces, and it also has the digits 2 and 1. So if I say, is that alpha, it's going to come back false. Whereas ABBA AZ only contains letters, so that's true. If I have ABBA AZ and the number 4, that comes back false. Okay, so spaces and numeric digits make that false. Okay, here's a multi-line thing, and you can do stuff, right? You can make it all uppercase, and it turns everything uppercase. You can split it, okay, and it turns everything into, it splits it, and notice how it treats the word I've, okay, and the word don't, all right? So everything else appears with single quotes, but I've will appear with double quotes, I apostrophe VE, and then don't, again, also appears with double quotes and things like that, okay? And there's nothing special happens between hallelujah and well. Those just appear as separate things. So it treats the regular space and the new line character as the same, and just splits those. Doesn't kind of give any kind of special treatment there. Okay, you can also do a split line. Split line is different from just a regular split. Split will separate out spaces or any kind of white space character. Here, split lines, it only goes at the new lines, right? So we've got the first one is lyrics to the songs Hallelujah. And then here, it takes the first line, well, I've heard there was a secret chord, and new line there. And again, because there's an apostrophe here, we get the double quote. Here, there's no apostrophe, so you get single quotes. It defaults to single quotes. And then whenever you have apostrophes, it's going to use a double quote to kind of compensate for that, okay? You can say, you know, how many times does the character E appear? And it goes through and counts all of them up, and it says, you know, it appeared 15 times in this string, okay? You can say, all right, I want to search for a letter, okay? Search for a letter. And so this is one way to accomplish this is I've written a string, or what if this sentence includes both that and that? Well, then it'll return one of the characters will be escaped. Okay, so you can escape quotation mark. or something like it. Okay. All right. So this is one way to kind of find where it is, and this will be like kind of the first index. So the character T appears in index 7. And the way I achieved this was just running kind of this while loop, starting at index 0, where you just kind of increment the index. And then if once it achieves, finding that string is looking to the letter, finds the letter that you're looking for, it returns that. Otherwise, it's going to return a -1. Similarly, there is a method called find, which pretty much achieves this. Okay. And you can say, well, find the character T, and it gives back 7. And there is a string.find and string.index. They're pretty similar. The only difference here is that .find will give you a -1 if it can't find it. So if you say find the character $, it comes back and gives you a -1. If you say give me the index of the $, you're going to get an error there. Okay, so that's the difference between find and index. So they're similar, but different results when you can't when you give it something that it can't find. Okay, I'm going to just blitz through this part. The in operator is very useful. It can also be used for lists as well, and you can say is A in the is the character A in here? That's going to be true. Is the string nan found in bananas? That's true. What about bad, BAD? That's not found in there, false. Okay, so you can kind of do this, find if the string is subset there. Okay, and then as far as string comparisons, I think I've already had a slide on this as well. But basically, it's an alphabetical order where all the capital letters come before all lowercase letters. The digits get treated as characters, and so if you were to alphabetize using 11 and 101, numerically 11 is less than 101, but as far as strings go, 11 comes after 101, as far as like alphabetizing using strings, right? And I don't know, you might have noticed this like in your own file system when it comes to like sorting values and stuff, okay? And then this is like, what is the order of the symbols? And this is like a totally arbitrary thing, but this is technically the order of the symbols that appear in Python. So the exclamation point is kind of the earliest in the thing, and then it goes in this order, and then these appear here, and then these appear here. So who knows what the order reasoning is there? It's fairly arbitrary, but that's the ordering of symbols in Python as far as what alphabetical order looks like for Python. Okay, let me give you the last view quiz answer for today. Last view quiz answer is the letter E. The letter E as in elephant is your last view quiz answer. I've got another homework assignment coming up. I should get it posted either tonight or tomorrow, and I'll make sure you guys have at least 1 week to complete it. So another homework assignment will get posted, and then I'll also probably post a couple chapters from Data Camp as well. So we'll end here for today, and we'll see you guys on Wednesday. Have a good night.